to Aksharashala. In this video, I am going to introduce various programmable logic devices like ROM, PAL and PLA. Let us implement some problems by using these programmable logic devices at the end. Various ICs are used for performing basic digital operations and other functions such as multiplexers, demultiplexers, adders, comparators, code converters, shift registers and counters. So all these are multiplexers and demultiplexers, adders, comparators, code converters will come under combinational circuits. Shift registers and counters will come under sequential circuits. That means for performing combinational operations as well as sequential operations will be performed by using ICs. These ICs are referred to as a fixed function ICs. Each one of them performs a specific fixed function. That's why these ICs are called fixed function ICs. These devices are designed by their manufacturers and are manufactured in large quantities to meet the needs of a wide variety of applications and are readily available. To design a circuit, a designer can select from the available ICs which are most suitable to the circuit, usually working from the block diagram design concept. The design may have to be modified to meet the special requirements of this device. What are the advantages of this method? Suppose if we implement a digital function by using fixed functions, what are the advantages? Cost will be low. You can design the circuit within a less time. Easy to test the circuit. These are the advantages offered by fixed function ICs. Suppose what are the disadvantages of this method? Let us see. So space will be wasted. It requires more power, lack of security. Other circuits can be copied by others. Additional cost, space, power requirements, etc. are required to modify the design or to introduce more features. It is not possible with you if you implement logic function by using fixed function ICs. To overcome all these disadvantages offered by fixed function designs, application specific integrated circuits are being developed. Application specific integrated circuits are designed by the users to meet the specific requirements of a circuit and are produced by an IC manufacturer as per the specifications supplied by the customers. Usually the designs are too complex to be implemented using fixed function. So what are the advantages of ASIC designs? Let us see. So it reduces the space, power also reduces, cost also reduces, size drastically decreases. So if size decreases, we can embed more number of devices. So level of integration also increases. So this type of designs are impossible to copy. These are the advantages offered by ASIC designs. What are the disadvantages of ASIC designs? Let us see. Initial development cost will be very high. Testing methods also somewhat difficult for these ASIC designs. Another approach which has the advantages of both means fixed function designs as well as ASIC designs is programmable logic devices. This is the third method. A programmable logic device is an IC that is user configurable. Suppose if you want to modify any parameter, you can modify at your end. It is capable of implementing logic functions. It is a VLSI chip basically that contains regular structure and allows the designer to customize it for any specific application. Suppose if you want to load AND program, it will work as a AND gate. That is, it is programmed by the user to perform a function required for his application. PLDs have some advantages over fixed function ICs. Design cycle will be very short and cost also very less. Advantages over fixed function ICs are, so all the fixed function limitations are overcome by these PLDs. So all these limitations of fixed function ICs are overcome by PLDs. PLDs have many advantages over I6 also. Higher size drastically decreases, lower quantity production costs, design security, power requirement also reduces, space drastically decreases. These are the advantages of PLDs over A6. PLDs allow designers more flexibilities to experiment with designs because these can be reprogrammed in seconds. You can just erase and reprogram it once again, so it will work for your application. The design deficiencies and modifications etc. can be carried out in a short time. This is the advantages of PLDs, thereby reducing the possibility of use cost overruns. So these are the differences between three designs: fixed function IC design, ASIC design and PLD design. Parameter wise, all these three parameters are compared, you can see here. Because of various advantages of PLDs mentioned above, a large number of PLDs have been produced by IC manufacturers with variety of flexibilities and options available for a circuit designer and have become very popular. The architecture and various other features of PLDs such as ROMs, programmable logic arrays, programmable array logic, simple programmable logic devices, SPLDs, these are also called as SPLDs. Complex programmable logic devices, CPLDs, and field programmable gate arrays have been developed. The use of these devices require changes in the traditional design methods, although the basic concepts remain the same. Logic in general, k variable n outputs logic function can be implemented using a ROM of size 2 power k into n, 2 power k equivalent to m. Since all possible 2 power k minterms are effectively generated. Since programmable ROMs can be used for logic design, therefore ROM also referred to as a programmable logic device. The advantages of using ROM as a programmable logic device. So design will be easy, no simplification or minimization of logic function is required. Designs can be changed, modified rapidly. It is usually faster than SSI MSI circuit. Cost also drastically decreases. These are the advantages offered by ROM when it is used as a PLD. There are few disadvantages with ROM based circuits, such as non-utilization of complete circuit, increased power requirement, and enormous increase in size with increase in number of input variables, making it impractical. These are the disadvantages of ROM based designs. Now let us see other PLD devices. A programmable logic device is an integrated circuit with internal logic gates that are connected through electronic fuses. The gates in a PLD are divided into an AND array and an OR array that are connected together to provide AND means product, OR means sum, and sum to implement a sum of product implementation. AND array, a series of AND gates and a series of OR gates are used to implement sum of product implementation, SOP implementation. The initial state of PLD has all the fuses intact. Intact means connected, short circuited. Programming the device, if you program the device, involves the blowing of internal fuses. Some of the fuses, selected fuses, are disconnected or opened to achieve the desired logic function. Initially all the fuses are shorted. So if you see this this slide gives the difference between ROM versus PLA and PAL. In ROM, fixed array, fixed AND array and OR array is programmable. In PAL, AND array is programmable but OR array is fixed. In PLA, both are programmable, and OR array, both arrays are programmable in PLA. Let us see the general structure of decoder. Here n inputs are decoded into 2 power n possible outputs. 2 power n possible outputs. If enable is 0, all the outputs are disabled irrespective of inputs. If enable is 1, when input is 0, y1 will be selected and that will be activated. If enable is 1, if input is 001, these are the inputs. When input is 001, its value is 1, no? So y1 will be activated. Similarly, if enable is 1, when ABC is 001, y7 will be activated. Like this, y7 will be connected, y7 will be selected. This is the logic diagram of 3 to 8 decoder. 3 to 8 decoder. So here 3 to 8 decoder, y0, 0, 0, 0, A bar, B bar, C bar. So this minterm will be implemented by using this AND gate. 0, 0, 1, y1. So similarly, 1, 111 is implemented by y7. In this way, we can implement 3 to 8 decoder by using AND gates. So read only memory, ROM. So given a 2 power k into n, where 2 power k represents number of memory locations in the ROM and n represents number of bits in that each memory location. So we can implement any combination circuit with at most k inputs and at most n output by using this 2 power k n ROM. K to 2 power k decoder. So to select any one of 2 power k memory locations, k inputs are required. To select 1 among 2 power k by using k inputs, decoder is used. This decoder will generate all 2 power k possible minterms. That is the beauty of this decoder. Each of OR gate implements SOP expression. So here array of OR gate implements SOP, sum of products. All these products here, all these are D0 to D7 are product terms. All these product terms are added by using this OR array. AND gate is fixed. Here AND gate is fixed. This is AND gate. These are AND gates. These are fixed. But OR gate is programmed. This is programming. So here see F0. F0 is 157. So 1 D1 is programmed. Shorted. D5 is shorted. And 7 D7 is shorted. So that will be given to F0. Similarly F1, F2, F3. F3 you can see 2. D2 is selected and 5 D5 is selected and 7 is selected and given to F3. In this way we can implement any logic function by using ROM. So here 4x2 from using 2x4 decoder. So 2x4 decoder by using 2 bits we can select any one of 4 minterms. 2x4 decoder is required. Up to this is 2 power k implementation. So any one of 2 power k memory locations is selected by using 2x4 decoder. This is 2x4 decoder and 2 outputs are there. So here, so these 4 inputs, 2 outputs. So ROM size is 4x2. So this is implemented by using 2x4 decoder and programmable OR gates. Here OR gates are only programmed. So this is here implemented AND gates, OR gates and inverter. Same 4x2 PROM using 2x4 decoder, OR gate. These two are OR gates and inverter. So under inverter gates it is implemented. Let us see implement Boolean functions using ROM. Here F1 is given 1, 2. So here 1, 2. So this is 0, 1. This is 2. This is 3. So by using two inputs we can represent 4 minterms. So 1, 1, 2. F1 is 1, 2. So 1 is connected to F1 is here, no? So 1 is connected. So 1 is connected. Fuse is connected. Here 2 is connected. So 2 also connected. These two fuses are intact. Other fuses are disconnected. So F2 is 0, 1, 3. So 0 is connected, 1 is connected, 3 is connected, but 2 is disconnected. In this way we can implement this Boolean function by using ROM. Let us implement one more function by using ROM. Here three outputs are there, F0, F2, F3. Oh, F0, F1, F2, F3. Four outputs are there. Four outputs. So how many inputs are there? So totally 0 to 7 minterms. And 0 to 7 minterms means 3 inputs are required. So there are 3 inputs and 4 outputs. Thus we need 2 power 3 means 8. 2 power 3 into k, no? So 8 by 4 ROM is required to implement this particular function. So F0 is 157. So 1, 5, 7 are connected to F0. And F1 1, 4 are connected to F1. F2 0, 7. F2 0 and 7 are connected to F2. And for F3, 3 minterms are there. 2, 5, 7. 2, 5, 7 are connected to F3. In this way, we can implement this logic function by using 8 by 4 ROM. Implement using suitable ROM. So there are, so again here minterms are 0 to 7. So 3 inputs and 3 outputs, FGS are outputs. So we need 8 by 3 ROM block to implement this particular function. See here, let us see 3 inputs A, B, C. F is equivalent to 0, 1, 7. So 0, 1. This is last one, 7. This is 7. So this is 0, 1, 2, 3, 4, 5, 6. This is 7. So 0, 1, 7 are connected to F. Similarly, G, 0, 3, 6, 7 are connected to G, and 0, 1, 3, 5, 7 are connected to H. In this way, we can implement this logic function by using 8 by 3. Next, let us enter into PAL. In PAL, AND gates are programmable, and array is OR gate is fixed here. This is the general structure of basic structure of PAL circuit. Here AND gates, so all these features are programmed here. AND gate is programmed, but OR is fixed. OR is fixed. This is the general of PAL circuit. So here Boolean function F equivalent to A B bar C plus A bar B C is implemented by using PAL. So here A is taken, B bar is taken from here. So only A B bar and C first minterm is implemented by using this AND gate, and A bar B C is implemented by this AND gate, and this is unused. Why? Because total how many literals are there? 3 literals are there. So 3 literals means you have to use 3 AND gates. This is simply unused. For unused, all the features are intact, generally intact. Programming makes some of the features blown away. So in this way, we can implement this logic function by using. So here, these are the inputs. Total inputs are 3. So only functions with at most 3 product terms we can implement. So these 3 product terms. So here AND gate is programmed, OR gate is fixed. First output selection. This is second output. This is third output. Only functions with at most 3 products can be implemented by using this. Here you can see A, B, C, D, E, F. So this many inputs are there. So here only functions with at most 4 product terms. So in each output there will be 4 minterms, 4 product terms will be there. So let us implement. In this output 2 product terms are there. In this output 4 product terms are there. So to implement this particular output, how many AND gates are required? 4 AND gates are required. For this only 2 AND gates are required. For this 3 AND gates are required. So to implement W, 2 AND gates are required. So remaining 2 are unused. So here AND gates are programmed like this. and OR gates are fixed. To implement AX, 4 AND gates are used to implement 4 product terms, and here 3 AND gates are used to implement 3 min terms in Y, and 1 is unused. Programmable array logic PAL. Implement given functions using PAL. W equivalent to 2 min terms, X equivalent to 2 min terms, Y equivalent to 3 min terms, and Z equivalent to this many min terms. So Z can be written as W plus A C bar D bar plus A B bar C bar D bar. So see, totally how many product terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, right? So if you replace first two terms with W, it is also come under 12. So in first min term, A B C bar, A bar, B bar, C D bar. So A is there, 1. B is there, 1. C bar means 0. Remaining D, W inputs are not there in this product term, first product term. So just replace these two inputs with hyphen. In second min term is A bar, B bar, C bar, D bar. So A bar 0, B bar 0, C 1, D bar 0. So W is not there in this min term. So just replace with hyphen. Similarly, you can write this PAL programming table for other product terms up to last, and implement this Boolean function by using PAL like this. So here AND gates are programmed, OR gates are fixed. In this way we can implement any Boolean function by using PAL. Now let us see PLA, programmable logic array. Here both the arrays are programmed, and AND gate array is programmable and OR gate array also programmable. The PLA doesn't provide full decoding of the input variables and does not generate all the minterms. Generate minterms as per the problem requirement. Product terms are generated by programmable AND array. Sum of products is generated by programmable OR array. Let us implement this Boolean function by using PLA. So this is one first product term, second product term, third product term. AC is repeated. Already in F1 AC is there. So this is not considered as separate product term. Already covered. So this is fourth product term. So 4 product terms are there. So give a number to each and every product term, 1, 2, 3, 4. Inputs, totally A, B, C inputs are there. Outputs are F1 and F2. So in first product term, A, B bar. So A is 1, B bar means 0, C is not there in first product term. That's why it is replaced with hyphen. So AB bar is in F1. So F1 will become 1. AB bar is not included in F2. That's why F2 is replaced by hyphen. In this way, AC included in both the outputs. That's why F1 is 1, F2 is 1. AC means A is 1, C is 1. Here B is not included in this product term. That's why it is replaced with hyphen. In this way, you can write for other product terms and implement these product terms. So totally 4 product terms are there. 4 AND gates are required. So 2 outputs are there, F1 and F2. So 2 OR gates are required to implement this particular logic function by using PLA. So similarly, you can implement this function. So total inputs are ABC, outputs are 4 outputs are there, F0, F1, F2, F3, and product terms are A1, B bar, C bar, second one, AC bar, third product term, AB, fourth product term, B bar, C bar already repeated, this is repeated, AB is repeated, B bar, C is new, and A already repeated. So only 5 product terms are there. So 5 AND gates are required to implement these 5 product terms. Write its programming table and implement by using PLA. Here AND gates are programmed as well as OR gates are programmed. Both are programmed. So you can use this symbol. If you take output at this point, it acts as a buffer. If you take output at the bubble, it will invert the input. So in place of this, you can make use of these symbols also. And OR gates. So this is one more problem. Here 4 outputs are there, 3 inputs are there, and total minterms is 0 to 7 only. So 3 variable, and it means you can get a maximum of 0 to 7 minterms. So simplify each and get simplified expression for each and every output variable. You will get simplified Boolean expressions for each and every output variable. Implement these output simplified logic expressions by using and OR gates. This here I try to compare these 3 PLD devices, PROM, PLA and PAL. In PROM, under is fixed, R is programmable. PLA, both are programmable. In PAL, R is fixed and is programmable. This is cheaper and simple to use. This is costliest and complex. This is cheaper and simple. So all minterms are decoded. Here under array can be programmed to get desired minterms. Under array can be programmed to get desired minterms. Only Boolean functions in standard SOP can be implemented using PROM. Any Boolean function can be implemented. Here also any Boolean function can be implemented by using PAL. So similarly, we can implement this function also. Here 2 outputs are there, 3 inputs. Get a simplified expression for each and every output F1 and F2 by using K-maps, and implement by using PLA structure. Here AND gates are programmable as well as OR gates also programmable. For any queries, please contact aksharashala@gmail.com. For further updates, please subscribe to Aksharashala. Thank you.